Okay, this is another method of flexible pavement design. We call this as Overseas Road Note 31. And this is a guide to the structural design of bitumen surface roads in tropical and subtropical countries. You must be wondering why I am teaching so many methods of flexible pavement design. The reason is that there are some methods that is very good in designing the main structure of the pavement, and that's H2 road node H2 method is one of them. That if you want to design a main pavement like a main traffic lane, then you use H2 method. And sometimes in order to supplement H2 method, another method is asphalt institute method. But now there you have a chance to use unconventional bases like asphaltic emulsion basis, asphaltic cutback basis, and also other type of bases, or even to design a full depth asphalt concrete pavement. Now, what left is today is the Overseas Road Note 31 method. Remember, this method is very useful in design of your shoulders. If you want to design a shoulder, especially for your expressway or motorway or a rural highway, that's a very good method. It's a very simple method, and it has the advantage that you can design it. You can take this method also for a low volume road. So that's why, even though you can design a main traffic lane pavement from this Overseas Road Note method, then what I would suggest that you should design a shoulder. I mean flexible shoulder. You cannot design a rigid shoulder with it. So you can take this topic as a design of flexible pavement of low volume roads or design of shoulders. Before I move ahead, the shoulders are designed for 30% of the traffic load or 30% of E-cells to calculate. So if your E-cells is say 100 million, you can design traffic for say 30 million. So that's it for shoulders. And if you have a 50 million E-cells, then your total E-cells for shoulder will be 15 million. So that's why and the maximum traffic that is allowed for design with Overseas Road Note 31 method is 30 million. That's why I say it's very good method for a low volume roads or local roads. So what are the important aspects? There is a template that is available for each traffic and subgrade condition. And for that template, there are different materials that are being used in that template, and that is the part of this manual. So CBR greater than 80 for base material. They say if you have a CBR greater than 30 for subgrade, then sub-base is not required. If a CBR has CBR less than, a subgrade has a CBR less than 4%, then you use gapping layers. And then There are two types of surface dressing: single surface dressing and a double surface dressing. That's why I say this is the best method for designing a shoulder, because our shoulders are normally SST shoulders or DSD shoulders. So when say single surface dressings, they are normally adequate when applied to a bituminous layer. To be satisfactory for non-bituminous surfacing, the quality of single seal must be very high, and subsequent minor maintenance must be carried out promptly when required. It is recommended that double surface dressings are always used as a non-bituminous layers. The quality of double surface dressings will be greatly enhanced if traffic is allowed to run on the first dressing for a minimum period of 2-3 weeks, and preferably longer, before the second dressing is applied. This allows the chipping of the first dressing to adopt a stable interlocking mosaic, which provides a firm foundation for the second dressing. If the traffic results in the contamination of the surface dressing with mud or soil, this should be thoroughly cleaned off before the second dressing is applied. Sand may sometimes be used as an alternative to chippings for the second dressing. Although this cannot contribute to the overall thickness of the surfacing, the combination of binder and sands provides a useful grouting medium for the chippings of the first seal and helps to hold them in place more firmly if they are poorly shaped. A slurry seal may also be used for the same purpose. Those of you who have already taken that highway material course, this dressing and this slurry, that is not alien to them. Then there is another type of surfacing, that is a flexible bituminous surfacing. You can call this as flexible asphalt surfacing as well. So it is essential that a thin bituminous surfacing 50 mm, so this is what we call asphalt varicose, generally recommended for the structures described in chart 3, 4 and 7 of the structural catalog are flexibles. This is particularly important for surfacing laid on a granular road basis. Mixes which are designed to have good durability rather than high stability are flexible and are likely to have sand and bitumen contents at the higher end of the permitted ranges. In areas where the production of sand size material is expensive and where there is no choice but to use higher stability mixes, additional stiffening through the aging and embrittlement of the bitumen must be prevented.
सर आप स्लाइड्स चेंज कर रहे हैं क्या, क्योंकि ये
No, no,
स्लाइड्स
it's
आगे
not.
नहीं जा रही हैं.
Not, I'm not changing the slide.
ओके सर.
By applying a surface dressing, is this a problem? Okay, can you see this slide now? New slide, or yes or no?
So we can see this slide which says overseas road note 31.
It's nothing more than that.
As per a guide to the structural design register heading.
Is this changing now?
No sir.
No, sir.
No.
Okay, I'm afraid I have to stop here and I go, because that has been already recorded. So I'll just stop here, solve the problem, and we record it again, right?
Okay sir.
Okay, let me see. Okay, Farhan, I got you. Okay, can you see now this slide?
Yes, sir.
Yes, sir.
These parent finds are the finds developed like this.
Yes, sir.
Yes, okay. Now it's okay. So I will edit the video accordingly, right? Okay.
Okay.
Just a moment. Is this now changed or not? The second slide now in dry bound mechanism. The slide changed or not,
Yes, sir.
sir? And about this, what can you see?
The nomenclature.
Yes, okay. So I think now it's working, right? So I start once again. Now, another materials that is being used and it's a part of the template is the parent fines that are the fines developed during crushing of the rocks. These are usually 5 mm or less in size. These should be used to fill the voids of aggregates. The macadam developed the design procedures for the construction of pavements. Not the macadam, actually he was macadam. And particle size is 37.5 mm or 50 mm in dry bound macadam and water bound macadam courses. Now, the difference between a dry bound macadam and water bound macadam is the way the voids are filled with parent fines. In dry bound macadam, we use vibrations to fill the parent fines into the voids of gravel, or you can say we use a vibratory roller. In a water bound macadam, water is used to fill the parent fines to voids of gravels. This technique gives better results normally to fill the voids. But the problem is if the subgrade is clayey, then water will reduce its strength. So in another word, you can build your aggregate base courses either of two methods. One is if you have a good subgrade, gravelly or rocky something, then it's better to have a dry bound macadam. But if you have a subgrade that is clay, then you will always use dry bound macadam. And if your subgrade is not clay, then use water bound macadam. So in another, what I'm trying to say is that the dry bound macadam is useful for both of the case, irrespective of these subgrade condition. But the water bound macadam, it is effective only when your subgrade is not a clay soil or something like that. Now, if you look at the basic section, then you know that in asphalt there is a surfacing that is a wearing course and base course. The road base that we usually call this as crush aggregate base. The sub base we call this granular sub base and the subgrade. So what is the design process? You have to follow these 3 steps. There are 3 main steps to be followed. Estimate the amount of traffic and cumulative number of equivalent standard load, axle load, that will use the road over the selected design life. Here I'll stop a little and recommend you that whatever methodology you have adopted for estimating the amount of traffic and number of equivalent single axle load that will use the road over the design life, you use that you normally use in H2 method of pavement design. Because the different methods you use may have a different calculation of easels, But the more effective way is to always calculate the E cells using H2 techniques. Normally you are on the conservative side, and that's good for the pavement, because you never know what will be the life of the pavement, what will be the traffic on the pavement in future. Always we may go for a conservative side. Then another thing you all know by now, that the strength of the subgrade soil over which road is to be built. Selecting the most combination of materials and layer thickness that will provide satisfactory service over the design life of the pavement. It is usually necessary to assume that an appropriate level of maintenance is also carried out. And if you look at this flow chart, you will find these major steps. Assess traffic. How? First, classify your traffic according to the class. I mean, how many single unit trucks, how many triple axle truck, how many quad axle truck, like that. Then you measure axle load. You have to design, you choose the design life, and you calculate the traffic or total traffic per design, per lane, per direction, per lane. The second step will be do the CVR test. You have to assign the climatic regime, test soils, define uniform sections, and design earthworks. Then you have to select the pavement materials, you have to locate the sources, test properties, accept, reject, or modify, and assess the severe sites. Then you have to assess or select your structure based on cost analysis. You have to also review the local experience, do risk analysis, and design the drainage. And last but not least, you have to build that structure. Now, this, if you look at this table, these tables are based on road note 31 method. So if you have say 1500 or 1500 1.5 kg of the load on an axle, wheel load is 1.5 and axle load is 3 kg, then you will use 0.01 factor. For say 8 ton, then you will use 16 as an axle load factor, axle load, and equivalent factor is 20.7. Actually, they have calculated this axle load over 8160 gram, or you can say 8 ton here, and power 4.5. This is somewhat similar to how you calculate load equivalence factors in the H2 method. Now, 8 categories have been defined by road note 31 method. If your E cells is less than 0.3 million, you say this is T1. If it is between 3 to 6, T5. What would happen if it is 3? Actually, if it is 3, then you will categorize this as a T5, not T4. And from 17 to 30, this is T8 category, so highest category of the traffic. So in other words, as I have defined, have described in the introduction, the maximum traffic load for this pavement design method is 30 million. So if your traffic E cells are more than 30 million, better you don't use this design, or don't use that service period. For example, if I say you are designing a road, say for 10 years, and you are getting say 31 million of 35 million of e-cells, so you can do two things. One is to use H2 method, that is that can cater for 50 million e-cells load, or Asphalt institute method that can cater for 40 million e-cells load. Or you can, if you know, if you think that you are going to design this with a road node method and you are very confident, then you have to change the design life. Maybe you take 7-year design life and recalculate your traffic. So you have to reduce your design life or service life of the pavement to use the values. Remember, you cannot extrapolate in a pavement design. Extrapolation is very dangerous. So don't try to play with these values. And don't risk yourself. Don't risk yourself. Don't risk your department or the agency that is asking you to design. The CBR range, S1 is 2 and SC is 30. So if you have 30 CBR, then you are using a very good material. You must be wondering, if you have a CBR of 30, why the hell you want to design a pavement on that, or maybe something else. Usually, you know, even if we provide improved subgrade, that's improved subgrade has a value of CBR say 20, maybe 25. So even there, this becomes very trivial to design a pavement. Just you have to provide the service. Normally CBR 30 material is a sub-base material that we use in our flexible pavement. So anyhow, this method has given you liberty to design for any CBR value. Another interesting thing is that even though the method is there, they are a very it's a very authenticated and very verified method. But usually the pavement design, like design engineers, they don't recommend flexible pavement, especially of any value less than 5. So if you have a CBR of less than 5, better to go for a rigid pavement. Now, what are the unbound materials properties? They have coded like this: GB1, it's a fresh crushed rock, dense graded, unweathered crushed stone, non-plastic parent fines. GB1B, it's a crushed rock, gravel or boulders, PI less than 6. GB2 is a dry bound macadam, and it follows the having a plasticity index less than 6, water bound macadam less than 6. Then there is GB3. This is naturally coarse graded granular material. It has CBR of greater than 80 and PI less than 6. You can use natural gravel and that have a CBR of greater than 30. And for gravel or gravelly soils, GC, it's a dense graded CBR, because you have to know these abbreviations, because they are present in your template when you read the paper. So what are the plasticity characteristics for granular subbases? We call GS. Liquid limit less than 35, PI less than 6, linear shrinkage less than 3. And if you have an arid and semi-arid zone, you have liquid limit less than 55 plasticity index less than 20 and less than 10. Then if you go for the treated basis, it is categorized as CB1, CB2 or CS, and they have unconfined strength ranges from 3 to 1.5, 3, 6, 1.5, 6 and 0.75. Then there are surfacing material, DSD. Normally DSD is not for category, traffic category. Not normally, it's the method doesn't recommend any double surface dressing for if you have a traffic category of T5 or greater. If you use the double surface dressing, then you can use GB1 material, and this if you have traffic category T6 to T8, use GB1A material. Then there is a flexible asphalt. You have to use this combination, GB1 or GB2, and T5 use GB1, T6 you don't use for another type of flexible asphalt T6 to T8, your combination could be GB1A. Then if you are using wearing course and base course, GB1A, and wearing course and base course, GB1 or GB2. There are different charts defined: chart 1, chart 2, chart 3, chart 5, chart 6. So to summarize that, you have traffic classes T1 to T8, and you have subgrade classes S1 to S6. With each number decreasing, your values are also increasing. First is T8, 17 to 30 million easels, and S6, 30 plus. These are the symbols that are being used: DST, flexible, and these are the symbols that will be used and that is being used in your template. So let's try to understand this this template. This is chart 1, where you are using granular road base with surface dressing, and you have to focus here. For example, if you have S1 and T4 is your category, you will use this section 300, 250, 200 and SG. But if your soil is S1 and your traffic is T7, you are not going to use this chart. This is how this chart is. So this chart actually will not be used for traffic category T7 and T8. Now, chart number 2, it is not applicable for T8 category. Now, chart number 3, normally T1 and T2, you will not use this chart, and so is for T7 to T8. And these are the sections, don't worry, you have to just, you say if you have S3 T1, you are not going to use. If your S3 is subgrade and you have a traffic category T5, you will use this section. So it's just a very simple and trivial way of knowing your sections. And that's why I say it's a very easy method, especially for shoulder design. Now, again, this column means that you are not going, this chart is not applicable for T1 and T2 traffic. It may, the designer, they doesn't think that it is useful to use chart 4 for such a low traffic T1 and T2. Here, now you can understand that you can use only this chart for T6, T7 and T8 categories. Chart 6 is like this, but again then there is a structural surface. Then you have semi-structural surface, again T1, T2, 3 is not applicable. Symmetric, so for this symmetric roadways T78, these chart will not be applied for traffic rated category T7 and T8. So this is how you design pavement using surface tracing method. I hope this is very easy. You have understood this table well, and you can design the pavement very easily. And again, I again repeat, try to design a shoulder from it, not a main surface. So that's end my discussion on row note 31 method.